This is the third video for October 23rd, October 24th, and we are looking at simplifying expressions involving inverse trig functions. Just going to do this one example here. If you don't fully understand, please feel free to ask questions. Also, we'll go over this more on October 25th, October 26th in class. But we have this, what we call a composite function. So it's sine of arc cosine of 1/2. Now, one student says, so do I look at this using PEMDAS? Also, I should say, we're actually going to look at this one. That's my fault. But should I look at this using PEMDAS? And I said, yeah, you should look at it using PEMDAS. You should think about doing the inside first, inside the parentheses first. And so we're going to look at this sine inverse of -6/7 first. And we can think about sine inverse as arc sine. It's the same thing. And arc sine, sine inverse, those are always, the inverse trig functions will always give us angles. That's what the output will always be, is an angle. So this will be an angle. Let's call it theta because we don't know what that angle is. So in class we said our job is to figure out what is tangent of theta. If we can figure out tangent of theta, then we're done. That's what this is asking us to do. A lot's happening. So one thing is, because it's, let me do this. Well, we can keep going. Because the output is theta, I could rewrite it like this. Which means that because they're inverses with sine inverse and sine are inverses, then the input and output switch. So the output becomes the input here, and the input becomes the output there. The input and output switch. So that's one thing we know, and then we're actually going to use this because we know that's opposite over hypotenuse because we're dealing with sine here. So we're going to actually use that to help answer what is tangent of theta. Another thing is we're dealing with arc sine. So because we're dealing with arc sine, we know already that it can't be in quadrants 2 or 3. Because it's arc sine, we know it's going to be in quadrants 1 or 4. More specifically, it's negative. The value, the fraction is negative. So because the fraction is negative, we know it will not be in quadrant 1. So it has to be in quadrant 4. Because everything is positive here. Arc sine is only defined, the range is only defined in quadrants 1 and 4. So we know our triangle has to be here. And so we can draw our right triangle. Here, always go straight to your x-axis. Our angle theta is going to be closest to the origin. And we know that sine is opposite over hypotenuse. So if I'm looking here at theta, our opposite side will be 6. Our hypotenuse side is going to be 7. And one of those values has to be negative because I have this negative in front. Two ways of thinking of it, the hypotenuse will never be negative. So that will be positive, which means the 6 is negative. Another way to think about it is because you're going down from here, we're going in the negative y direction, which means that the negative, the 6 is on the negative as well. So we have theta, we have our opposite, we have our hypotenuse, and we want to find tangent of theta. So we're getting closer, because we have our theta here. Now we know tangent is opposite. We have our opposite side. Tangent is opposite over adjacent, and our adjacent side is here. So we actually need to use Pythagorean's theorem so that we can solve for the adjacent side so that we could do opposite over adjacent. So if we do Pythagorean's theorem, it would be -6 squared plus b squared equals 7 squared. 36 plus b squared equals 49. Subtract the 36. And if we take the square root of both sides, we would get b equals square root of 13. Now, only thing is, if we take the square root of both sides of an equation, we technically need this positive or negative. It could be positive or negative square root of 13. And that's important because this side here is either going to be positive square root of 13 or it's going to be negative square root of 13. Because we're here at the origin and we're moving to the right, it's going to be positive square root of 13. And from here, we can find tangent. Tangent is opposite over adjacent, or in other words, negative 6 over square root of 13. We know that we cannot have a square root in the denominator, so we multiply by square root of 13 over square root of 13. Negative 6 times the square root of 13 would give us negative 6 square root of 13. And square root of 13 times the square root of 13 is just 13. So this would be our solution, just from that little problem, all of this work to get to a solution. Again, we'll get more practice with this on October 25th and October 26th. However, you do have, this is a little tedious. It can be a difficult concept to grasp sometimes. So if you have questions, please feel free to ask me. Come to tutoring, come during study hall, ask me during class. We'd love to answer those questions, or through the Remind app or the website. Please feel free to ask.